Hello, everybody. Hope everybody is continuing to do well out there. Today's lesson is going to be on chemical reactions. We're going to continue to build off the things we've been talking about the last couple days. My last lesson was with physical and chemical characteristics. Things like we said, this was the example I used, my little guy here, that some physical characteristics of him would be things that pretty much like we can see, things that our senses can pick up. Okay, and that is a common mistake that I was seeing on a lot of your grade or on your assignments. A lot of you put down that the odor something gives off is a physical character or is a chemical characteristic. Now, it may be going through a chemical change, which I'll talk about here in a minute, but it's actually the odor that it's giving off is physical. Okay, same way with the taste of it, same way with the color of it. Okay, so basically, things like your senses is going to be something that is going to be, for the most part, is going to be physical characteristics. Okay, so we talked about physical characteristics, chemical characteristics, and then Miss Mills talked about, on Thursday, talked about our physical and chemical changes. Okay, and so that's where we're going to pick up today. So today, the things that you're going to be given on Classroom are your notes here, which we're going to go over in just a second, and you're also going to have your assignment here, okay? And we'll go over that a little bit later. All right, so basically, your assignment today, or your lesson today, like I said, is over chemical reactions. It's how things react, or how they act whenever they are joined together or whenever they're split apart. Okay, so a chemical reaction is a process in which substances undergo chemical change. Okay, they're going to be changing into basically into something new. Okay, now how that works is in the second part here. It says the atoms rearrange and new substances are formed. This new substance will have new and different properties, and this is a question that was on a previous assignment as well, that some of you did get wrong, because I think it said physical change was this, and that would be false. That this is a chemical change. And so, whenever you're going to have something going through a chemical change, it's going to create something new. Something in it is going to change, which is the third thing on here, where it says some clues that this is happening is production of a gas. That's a common one. You'll see smoke coming off of it, or you'll see, or you'll smell sometimes the gases coming off of it. Those gases, while they're a physical trait of whatever it is, the gases show that there's an actual chemical change that is happening. Okay, so you'll get that gas, or you'll get sometimes a solid, or which is called a precipitate, is a scientific fancy name for it, that's going to form, or you'll see a change in a color. And one of the most common chemical changes that we see, you can see here on the second slide, is fire. Okay, something burning. So it could be, wood burning. It could be a variety of different things that are on fire or that are burning. Okay, so the big thing, like I said, this we've kind of already gone over that part so far. You did with Miss Mills, but the part that I want to kind of stress here before we go on is there are basically two types of chemical reactions that I want to focus on. We have discussed this before, back when we were in school. However, we did not go over it in great detail, and so I kind of wanted to just stress it one more time because it's important for this as well. And those are endothermic and exothermic reactions. Okay, and basically the difference between the two is endothermic is going to take heat in, and exothermic is going to let heat off. Okay, so the way that I've always remembered this is exo is like exit, so that heat is exiting. Endo is like into, and so the heat is coming in. Okay, and so both of those are going to be where energy is released or given off, and are going to be some kind of change that is happening. Okay, now in this case here, the water is just melting, so it's still just a physical change because the change of state is still physical. But here with this one, this is an exothermic. Something is going to be, if it's wood burning or something like that, that is going to be a chemical change. Okay, so in an exothermic reaction, like when a candle burns, heat is given off. Endothermic, it's taken in. An endothermic, an example of that would be vinegar and baking soda. When that happens, if you ever kind of touch the glass that it's in, you'll kind of feel it it should be kind of cooler, a little bit cooler than it was before then. And that's because the heat of the glass is being taken in. And so it's an endothermic. So, like I said, that's kind of just a little bit of a brief overview, reminder of how those things work, because you will need that for your assignment today. In addition to that, we're going to then move on to, get to the right part here, what happens when those compounds join together or when they try to break apart, when that reaction happens, when that candle is burning, when that ice is melting, what is actually happening like on a scientific level. And we can also put this as what's happening on a mathematical level. Okay, I've said this before that once you get to a certain state in in science, you kind of got to know what you're doing in math as well, and that's because pretty much anything in science can be explained mathematically, and so that's what we're going to be doing and taking a look at starting today, and then also on Thursday. So basically, what we're looking at is in those chemical reactions, how do we explain it mathematically? And so, what we're going to be looking at is we're going to be looking at something like this right here. Okay, we're going to be looking at what happens when you take two hydrogens, two oxygens, and you join them together. Okay, well, we know you get H2O, but how does that all come together? Whatever the part's called, all that stuff is what we need to look at today. So basically, all of this here, this is kind of like vocabulary, which I'll explain on the next page. But you'll need this for your assignment today. So just make sure you come back to this later on when you're doing your assignment. So basically, on this page here, this kind of explains how everything is. You've got what is called a chemical equation. Okay, those of you that are in algebra already, you should have seen some kind of equations like this before. Everybody else, hopefully you've seen a little bit of this. I know you've seen, we've already started putting letters into your math, so you've seen those before. Well, basically this chemical equation, like I said, this whole thing here is a chemical equation. So that's what number one is here. The whole thing is a chemical equation. You've got two parts to it. You start off with certain parts, certain atoms, certain compounds, and it can be atoms or compounds, and those are called the reactants. Okay, it's what's going to react. It's what's going to what's going to be changed. Okay, so in this case, we've got the two H2s and two O2s. Okay, so those are both the reactants. Okay, so if I asked you to list the reactants here, you would need to make sure to tell me basically everything on this side. Okay, then on the opposite side over here, you've got what are called the products. Okay, the products is what you produce. Products produce. So what's made? And so in this case, the two H2Os are the products. Okay. Now get a little more specific. The stuff underneath here, the number in front of the H2s, the two H2s, that is called a coefficient. When you're going to be dealing with chemical equations, that is the only thing that can be changed when you're trying to make this all balance out, work out, which we'll get into how that works later. But anyway, that's the coefficient. Okay, so this number in the front here, that is the only thing that will ever change. We never mess with these numbers in the back. Okay, these subscripts back here, they never get changed. Okay, they're always going to stay the same. You cannot change the back ones. So the coefficient is out front, the subscript is in the back. Then you've got the chemical symbol. We've been working with those for a long time now. You should know those. That's the O here. And then you've got something new here. This is the arrow is what's known as yields. It's kind of like your equal sign in math. Okay, so the arrow is the yields or the equals. And then finally, the whole thing put together, H2Os, two H2Os, is called your chemical formula. Okay, so you'll need those like specifics and everything for your assignment today, and possibly for a little bit on Thursdays also. I don't remember exactly which one that is. So when you are looking at these, basically what's happening on a molecular level is, for example, with this one here, the two H2s, two O2s makes two H2Os. So we put these together. We did this a couple days ago. We see that how when I take two hydrogens, they're bonded together right there. That little line in the middle is a bond. So if I take two of those together, it's like writing it this here, two H2s. Okay, each of these has two H's, so two H2s, plus an O2, so just one of the O2s, one molecule of oxygens here. So in other words, two oxygens joined together. So plus one O2. Okay, we don't really need to put the one in front of it, but you can if it helps. What that's going to do is that's going to yield. Remember, we said that arrow here means yield or equals two H2Os. So when you put them together, you get two water molecules. Okay, and that's kind of how that all works. Now, how this all happens, what causes it, this yields here, that's going to be kind of where you put in your energy. Okay, but we'll get into that more when you get up into chemistry in high school and everything and how that all works. But you got to add energy to it. Okay, usually in the form of heat. So again, what you have down here is you have four H's on this side of the equation, four H's on this side of the equation, four O's on this side of the equation, four O's on that side of the equation. I'm sorry, two and two, sorry. I said two, four O's supposed to be two O's. So two O's on this side of the equation, two O's on that side of the equation, okay? So anyway, what this does is this, it kind of shows how it equals out or it balances out, okay? Now, when you get further in, we're going to be looking at how do we make these balanced if they're not, all right? And so there is a mathematical way to do that and everything. We're not going to be getting into that this year. We will look to see if things are balanced or not on Thursday, but we're not going to get into actually balancing them. Okay, that's going to be high school. But you do kind of see how things are equaled out here. Okay. Let's see. Next. With this brings up a very important scientific law that you're going to come up against again and again and again when you're in physics, when you're in chemistry. This law is going to be talked about all the time, okay? And that is the law of conservation of mass, okay? And basically what that means is that matter or mass itself cannot be created or destroyed. Okay, so matter is neither created nor destroyed during any physical or chemical change. So what that means is back here, when I've got my fire here, I've got my candle burning, whatever, I'm not creating anything new by the candle burning. I'm not destroying anything. Okay, now you may say, well, when I burn a candle, all that's left is the wick and maybe that little metal or plate down at the bottom and a tiny puddle of wax, but that's it. So where'd everything go? I mean, you were destroying it. But in reality, you're not. What's happening is that wax is being burnt off. It's being turned into gas. That's why you see the gas coming off the flame, the smoke coming off the flame. And so those gases, the stuff that was trapped as a solid is now becoming a gas, okay? And so that candle is not being destroyed, it's simply being changed, okay? And so that's a very important law that, like I said, you're going to see repeatedly in science, the law of conservation of mass, okay? So that whatever you start with is what you end with. Ever since, going back to the beginning of everything, what was here at the beginning, Big Bang or whatever you want to call it, is what is here now. Okay, nothing's being created, nothing's being destroyed. And so that's called the law of conservation of mass. Now, I know there's going to be some of you that are going to question that, what about like black holes and things like that? Well, we don't know enough about black holes yet to really say if that violates this law. But for right now, what we do know, this is the law, okay? So, law of conservation of mass. To balance a chemical equation, you're allowed to change coefficients, but never the subscripts. So that's kind of what I went over earlier. On these here, you're allowed to change these numbers out front, but you are never allowed to change the numbers in the back. Okay? All right, so basically this kind of leads us to what you're going to be getting into with Miss Mills on Thursday. And that is, how do I check if they are balanced? Okay, the one that we looked at the beginning, okay, two hydrogens, two H2s, two O2, or I'm sorry, NO2, everything balances out here. Okay, you can see how it balances out. Well, what about when you're going through this and it doesn't balance? How do you balance it out? Well, that's the part where I said that there is a mathematical way to do this, and some of you will probably see it when you kind of look at these with Miss Mills on Thursday. But if you don't, if you think it looks like a bunch of Greek letters and things like that, don't worry. You're going to get into that later, okay? After your math brain has developed just a little bit more. And you'll be able to see it. The big thing that you're going to be doing with Miss Mills is just seeing, is it balanced? Do these balance out? Okay, for like this one here, we would obviously say no, it's not balanced. Okay, because both of these here have different numbers on each side. So because of that, we would just write unbalanced. Okay, now later on you would learn how to balance it, which is the bottom part down here. Okay, but for right now we're just simply concerned with, do they balance? Okay, remember, because of the law of conservation of mass, they have to balance. Okay, they cannot be unbalanced. They can't look like this. Okay, if they do, then that's totally violating everything we know about physics, about chemistry, about the law. And so because of that, we have to, mess with them and be able to figure that out. But again, that's for later on. So to kind of sum up what we've been talking about today, the big things that you're going to be leading into is, how do two or more elements come together? How do we keep them balanced? How do we keep them so that we're not trying to create anything new? We're just simply changing. Okay, and so that's kind of the big thing, the chemical reactions that you'll be focusing on for the next 2 days. Okay, so for your assignment for today, the first 11 is just simply looking at vocab. Okay, and so look at your notes, look at things like that, and you will find these answers in there. Okay, then the last part here, this part, is where you will use your notes, this here. Okay, and so what it's asking is, you're going to use this this formula right here, and you're going to type in here all of the reactants, and then make sure you type in all of it. And then what are the products? You type that here. So there's one reactant goes here, one reactant goes here, and there's only one product. Okay, so put those there. And then down below says how many Si atoms are on the reactant side. So remember, reactants is over here. How many Si atoms are on the product side? And then you're going to do the same thing for the CLs. Okay, the reason we're doing this is that I want you to start looking at, is this equation right here balanced? Remember, we got to have the same on both sides. There should be the same amount of SIs on the reactant side as there are SIs on the product side. Same amount of CLs as there are on this side. Okay, if there are, it's balanced. We're done. We're good. If it's not, down the road, there's going to be an extra step. Not today, not Thursday, in the future. Okay, so that is your assignment for today. Pretty self-explanatory as far as if you look at your notes. Okay, big thing today is going to be, make sure you use those notes. All right, guys. Hopefully I didn't confuse you too much trying to talk to you about what you're going to be doing with Miss Mills on Thursday also. But believe me, it's actually pretty easy once you get it. Okay, or once you're explained it. I think that's all for today. Hopefully you guys are continuing to do well. Only a few more days left with you. Sorry that I don't get to see you in person. But make sure that you guys do come down and see me when you do your A plus mentoring or whatever. I do hope to see you guys again.